Alright guys, we're going to start this year by just defining our number sets. So we know what we're working with, kind of the same symbols. Alright, we're starting with our natural numbers. Those are your positive whole numbers, so 1, 2, 3, and so on and so on. 100 and so forth and so forth. Pretty standard, pretty straightforward. The symbol for the set is a bolded N as such. So those are our natural numbers. Zero, I've seen books include zero, some books not include zero. For our purposes, it's just not included for right now in the natural number system. All right, then civilization kept improving. The brightest minds discovered zero. More time had passed, and then they discovered the negative numbers. So our integers are, and the recording of me, it's not going to be as clear because I'm writing on my tablet, on my laptop, and it's leaning against my leg, so the camera's a little off. All right, integers, all whole numbers. All right, negative, I don't know, 100, negative 101, and so forth and so forth. Negative 2, negative 1, we're going to include 0 now, 1, 2, 3, and so on and so on. So all the whole numbers, those are integers. The symbol for that set is a bolded Z. If you're handwriting it, just include an extra little line on this piece here. So those are our integers. The integers include the natural numbers. So here are your natural numbers, which are part of the integer. So we're just expanding our number sets. All right, at this point, we're missing fractions and decimals. So rational numbers, any number that can be written as a ratio slash fraction. So it's going to include all the previous two sets, your naturals and integers. For example, any whole number can be written as a ratio. Let's put it over 1. So all the whole numbers, so all naturals, all integers, and any other fraction you can come up with. 2/3, 1/8, negative 3/7. Anything that can be written as a fraction is a rational number. To determine if a decimal is a rational number, well, it will end like 1.0875. That's a rational number. It is a fraction that can be written to represent that decimal. If it doesn't end, it'll be repeating. So if you see a decimal that repeats or ends, it is a rational number. If you wanted to write it as a fraction, you could. We just have to determine how many decimal places we have. So we got 0, what happened to my pen? Get back on there. 10875. What is that? Tens place, hundreds, thousands, 10,000s. So that divided by 10,000. And there's your fraction. Reduce as needed. So any decimal can be written. If it ends or repeats, can be written as a fraction. Next up, my irrational numbers. This is where it branches off. So we started with our natural numbers. We expanded on that by adding negatives and 0. We expanded on that by adding fractions and decimals. Our irrational numbers do not expand on that. Irrational numbers, it's a separate set. These are numbers that cannot be written as a fraction or a ratio. Examples of these, square root of 2, square root of 3. There'll be a lot of radicals, as well as multiples of those values. So I don't know, 3 times the square root of 5, we can even add to it. That's an irrational number. There's no fraction that represents that. We also have others, such as our transcendental numbers. Pi cannot be written as a fraction. 22 over 7 is a very close approximation, but it is not it. E, or e to any power for that matter, e to the 1, e squared, and so on and so on. So those are your irrational numbers. And all of the above composes the real number system. So everything we discuss are part of the real number system. Your real numbers are any numbers without an I component, which will take us to the imaginary number system, which we'll talk about in a second. So real quick diagram. Let's see what this would look like. So that's our real number system. I'm sorry, I forgot the symbols up here. Your rational numbers are Q. Irrational numbers, well, your real numbers are R. Irrational numbers is written in numerous ways. I kind of like this one, your real numbers without the rationals. But don't worry, don't get hung up too much on the symbols for irrational numbers. All right, real numbers, that's everything above. So we have our irrationals here. Over here, we have our rationals. Within the rationals, we have our integers, which are positive and negative whole numbers, and 0. And within that, we have our natural numbers. You'll see numerous diagrams regarding these, but that's pretty much a common way of doing it. So the entire thing is reals. These are all real numbers. Within the real numbers, it splits up. Irrationals and rationals. Irrationals and rationals over here. Within the rationals, we can break it up to just whole numbers, positive and negatives. Within the integers, we can shrink that set even smaller to just positive whole numbers or natural numbers. So the history behind this is really cool. I can't recall too much of it, but dawn of civilization, they started counting with just our natural numbers. You got 1, 2, 3 cavemen. We need 1, 2, 3, 4, 5 rocks for whatever. Then again, society advanced, civilization advanced. The number 0 was discovered hundreds of years later. Then negatives, then fractions and decimals, then irrationals. All right, so that's your real number system. Outside of the real numbers are imaginary numbers. So we let I be equal to the square root of -1. That is an imaginary number. An imaginary number is any number that has that as part of it. So a plus bi, where a and b are real numbers. So for example, 2 minus 3i, that's an imaginary number. 6i, that's an imaginary number. -8i. What else? Oh, pi times I, why not? So anything times I. Those are imaginary numbers. All of the above will be your complex number system. So we're going to make another diagram. It would break up. So these are all my complex numbers. Within that, we have our imaginary numbers. You have your real numbers. And then again, the real numbers, we can reduce that set over and over again. Just the rationals. We can reduce that, just the integers. We can reduce that, just the natural numbers. So right here would be your irrationals. All right, so those are your number sets. We will be playing with these all year. Review this video. If you don't have a chance, it's fine. I will go over this again during the first day of class. That's it for this one.